So why remote attestation is the next business driver? I have 56 slides and 15 minutes, so let's see how it goes. So first of all, the joy of attestation. Attestation is fantastic. Confidentiality and integrity are brilliant, but without attestation, they are not that useful, and with attestation, things suddenly get really interesting. So what I want to do is to, firstly, just remind everyone what attestation looks like, then say, well, what might we be able to do with that, then go through some use cases, and then think about how we might extend those use cases. So this is how I think of the world. You have, in the right, a TE, and that has an application, the pink bit, and some data, the orange bit. And it sits inside a box, which is kind of the TPU, the TE, and it's managed by a CPU or GPU, and on the left you have a user. So the first thing you want to do is have that measured. So the application says, please provide me with an attestation measurement. And that's what the CPU does. That's basically a hash of the cryptographic hash of what's in the TE, which is signed cryptographically again by the CPU or the GPU or in the future NPU, whatever. And that is passed to an attestation service because someone needs to check that that's been done right. Yeah? And it might be you running that, it might be a third party, it doesn't really matter in this case. But that data is sent along to the attestation service. And the attestation service says it's good, then the user said, that's fantastic. I know a few things here. I have assurances that firstly, this is running on valid hardware, that it's been correctly set up, and that the software in the TE is what I expected in the first place, right? So this is great. We've really got ourselves a new set of assurances. So what does that allow me to do? What can I build on top of that? So the first thing to be aware of is that is basically a certificate, right? That's some data which has been signed. And if you think of that as a certificate, or you can build a certificate around it, suddenly there's a whole bunch of things you can do with that data. So the first thing, you could use it for transport encryption, for something like TLS, right? That's what we use certificates for. That means that you can talk to that TE and be sure what you're talking to. We could use it to prove identity. Again, certificates are really good for that. And so that's another thing. We can use it to prove uniqueness, because each of those measurements should be different if we do this right. We can extend it to allow it to sign the output of what's coming out of that TE. So we've got ourselves a bunch of assurances on top of the confidentiality and integrity that we already cared about that we could do some really interesting stuff with. So let's see what that means. Let's try combining those properties. So my first use case is CC, confidential computing, and AI. And so this is how I see the world, okay? If you see the world differently, I apologize. But let's say on the left, we're going to do some training, okay? And the training has a training model and, let's say, a couple of data sets, which are being used by that training model. We're going to put them in a TE. All good so far. And we're going to do an attestation measurement. We now have certainty as to what is in there, and it's been signed. So this means that we can protect the confidentiality and integrity of those data sets from people who shouldn't be looking at them or playing with them. And we can also protect the confidentiality and integrity of the training model. So we've already got some useful properties, right? But once we've actually got the output of that, we can actually take that attestation measurement and put it into the inference engine as well. So that basically means we can be sure that that inference engine came from that data and that model that we had on the left, right? So we've now got some really interesting provenance information. And also, we can take a attestation of that, all of that as well, and we can then protect the inference engine as well, again, to make sure that no one messes with it or looks at our private data, if we're taking a RAG approach, for instance. And last but not least, remember I talked about using that for TLS or for communications? Well, when we're actually asking our question of the inference engine, that can be protected, and the answer is protected as well. which means that we've protected all of the pieces along the chain. We have got the integrity and confidentiality of the data sets, of the training model. We can track the inference model's provenance all the way out to the user, and we can protect the inference engine confidentiality and integrity and the query and response information, all by using attestation. So there's quite a few steps in here, and it takes a bit of building, but this is a really good example of how you can use attestation to do some really clever stuff. So, that enough for you? Well, you've got more. So, next use case is confidential computing and multi-party collaboration. So, we're going to look at a couple of use cases. The first one is financial collaboration. So, here we've got some mutually distrusting parties. Let's say you've got a bunch of different banks who, let's face it, don't entirely trust each other. Would you trust a bank if you were another bank? Probably not. However, they do have some things they need to do together, and they need to do some computation together. Maybe it's reconciling some transactions, maybe it's doing fraud prevention, it could be a bunch of different things. But let's say we've got 3 different banks with 3 different data sets, okay? And they have an application that needs to run on those data sets. So let's first of all put it in a TE, right? Because that's what we do with everything. We put things in TE, because why wouldn't you? And the first thing we're going to do is we're going to measure that collaborative application by taking a hash of it and sign it, which means that as long as those banks have previously had a look at that application, because they've shared it to check what it is, they can be sure that what is in that TE is what they expect should be in that TE, which means that they should now be happy to put their data sets in that TE, because they can be sure, firstly, that no one can mess with their data or that application. So even if that's running on a cloud they don't trust or being run by one of the other banks they don't trust, their data is safe. But also, they can be sure that the application is the one they think it is. It's not going to take lots of personal and identifiable information and give it to someone else or expose people's bank accounts or anything else like that. So this is a really good thing. And once more, once we've actually finished it, because we can use the same information for the attestation to sign the output, means they can trust the output as well. So we've just allowed them to work together despite the fact they don't trust each other. This is a very good thing. So first of all, we prove the correctness of the application. Then we protect the confidentiality and integrity of the application. Then we protect the confidentiality and integrity of the data sets. And last but not least, we can trust the output. Really, really useful stuff. So, everyone following so far? Nod, nod, nod. Okay, so pharmaceutical. I don't know how to go back. Let's try that. There we go. Again, we've got a bunch of people who don't necessarily trust each other, but specifically, what we're going to look at here is we've got a pharmaceutical research company, and the pharmaceutical research company wants patient data from a bunch of hospitals. So if I'm a pharmaceutical company and I say to you guys as hospitals, give me your patient data, you're going to say, well, we'd say in the UK, not on your Nelly. Definitely not. We're not going to give you that data. So we want to find a way around that because we want to make sure that this can happen so they can actually do some work, but that they don't get all of the data. So let's have a look how we might do that. So here we've got a couple of different hospitals and the pharmaceutical research company. I spend a lot of time on these icons, and I don't want anyone criticizing them. Okay? So, first of all, I've called them HH and P because it was too long to type and I couldn't be bothered even to copy and paste. So, first of all, what's going to happen is that pharmaceutical research company is going to create an application, okay? And that application is going to look at maybe the age and the gender of these people, maybe their weight and some other things, and it's going to do some calculations, and it's going to spit out a, yes, they are more likely to get cancer than not, for instance, or a 70%. But it's never going to take all of that data out. It's only going to give a yes or a no answer, or something that can be derived from it. So we can prove, by looking at this application, that it's never going to leak any data that's given to it directly, okay? That's really important. So what happens then is we take a hash of that, cryptographic hash, and it might be checked by the hospitals themselves or by a third party, it doesn't really matter. But what the important thing is that we send that hash to the hospitals, which means that when that is run inside a TE, and that TE has an attestation measurement, they can now check that that attestation measurement is what they expect. And they can be sure that what is happening in that TE is what they expect. It's the application that they originally saw, which means that they can be happy that they can put their data sets in it. I'm not going to go through all of this because I'm running out of time horribly. So that means they can now put their data in there. That data is protected, the confidentiality is protected, which is really important to the hospitals, and the integrity of the data set is protected, which is really important to the pharmaceutical, because they want to make sure they're acting on proper data, right? And the output comes out, and because it's been, again, we've done the attestation, we can be sure that what the output has come from the actual data sets and from the actual research app. I have 4 minutes, 3 minutes. All right, so we've done all these things, they're lovely. Look at this on the recordings or online. So let's get to the final thing, which is how do we categorize these use cases? So I categorize them in 2 different ways, basically. The first one is use cases with multiple process stages. Lots of things happen in a row, and you want to be able to track back to what's happened for each of those. And you need to reestablish trust or build it over time for each of these process steps. And AI is a very good example of that. We've got the training engine, then the inference engine, and the queries. And we need to be able to backtrack trust all the way through it. The next one is where actually you've got multiple stakeholders who don't necessarily trust each other, right? And in this case, things like you've got financial collaboration or the pharma research. We saw that, where how do you build those together? How can you allow trust to be built up in a way that makes sense? If you're interested in trust, I have a book on the subject. Come and find me about it. No one reads it. It's very boring. Well, I liked it, but fine. OK, so finally, we have 2 different trust use case types. We've got multi-step processes and multiple stakeholders. And as I said before, the AI case is kind of the first case, and a financial collaboration is the second case, as is a pharma. But here are a few other use cases that you might be thinking about, and where do they fit? And I think they're interesting because, in my view, oh dear, there we go. In my view, they go across both use cases. They both have multi-step processes, but also they have this problem of multiple stakeholders who don't necessarily trust each other. I do have some slides for some of these as well, but weirdly enough, I didn't have the time to show them. So if you're interested, come and find me, and I will help you with that. So that is my LinkedIn. If you're interested in confidential computing, you should probably join the Confidential Computing Consortium, which is part of the Linux Foundation. I'm the executive director. We'd love to see you. Please get in touch. I have 1 minute. I presume you don't have time for any questions. If you have any questions, I will be over there. Come and find me. And thank you very much indeed.